mobility. So we aim to operate a totally zero emission fleet by 2040. And this implies a major transformation from our operations, our maintenance, our safety, HR, financing. So it's a transformation that covers all parts of the company. So it's a big challenge, and it's very important for us to use tools like the ones that are being developed here in eUltimate to have better information about this process and to allow us to take more informed decisions, better decisions when it comes to moving to zero emission vehicles. Without further delay, I would start to hand over to the speakers. In any case, just a very brief overview of the agenda that we have for this afternoon. So we'll have first an introduction by Marián Nick from the EIT Urban Mobility, like I already said. And then we'll have a presentation by Miquel Estrada, that is the coordinator of the project from the Universidad Politécnica de Catalunya. And we have a presentation specifically about the project, the work on this project at Carris, that is going to be made by Domingos Tavares, that works in the innovation department, innovation and strategy department. And following that, we'll have the presentation by Joanna Cunha of the new generation of micro simulation models that is being worked on this project. And André Castro, finally from ALMA Design, is going to present a station of the future in a decarbonized world. So I think this will be a set of 3 presentations that are going to tell you a bit more in detail what is the work being done in Lisbon in the framework of eUltimate, and also allow you to know more about the project and about the IT. Finally, and I would say in this case, definitely last but not the least, we'll have Paulo from CEIIA, which is a very important research organization in Portugal, that is going to have a keynote speech about decarbonization of mobility systems. So I believe we are all very much looking forward to that. I should have started by introducing myself, so I leave it to the end, but my name is João Vieira. I'm Director for Innovation and Strategy at Carris, and so in the specific case of this project, I'm ensuring the internal coordination of our team working on this project. So without further delay, and thanking again everyone that joined in the meantime for participating in this online event, I'll hand over to Marián for a presentation from EIT Urban Mobility. Thank you.
Thank you very much. Hello, everybody. My name is Marián Nish. I would like to thanks to all of you that you find time for this event, and I'm gonna share with you my screen to give you just a brief presentation about EIT Urban Mobility. I don't know if you see the screen right now.
Yes, we do. Okay,
great. So before I'll go to the detail of the projects and the necessity of the projects, especially in a field of supporting of e-buses and development of new environments for low carbon public transport, let me just briefly go through the through slide what is EIT and why we are doing what we are doing. So generally, EIT is a innovation, European technology for innovation, once again, European Innovation Technology Institute. We was founded 10 years ago with the different communities supporting, for example, energy, supportive e-health, supporting digitalization. And in our case, we was founded in 2019 with a aim to change how the people move. So we know that currently the cities are not very designed, not very optimal for new ways of movement. We have a new business model, new companies, and new challenges that lay ahead of us. So this is about like how we gonna change the way how we use the city for our movement. So we create systematic solutions. We are supporting new startups, and we are supporting also innovative projects like eUltimate. Very briefly, this was, I believe, presented also in a Zalaegerszeg in a press conference, just to give us a little bit helicopter view. So the patterns and the mainly technology grid, as you can see it, or the ranking 20 years ago was a mix of American, Japanese, and German, or generally European companies. And so the European companies was competitive with the other world regions. And in a 20 years or 17 years after that, we see that mainly China, United States, but also in case of Asia, Korea and Japan are way ahead of all the European partners or European countries in all the important fields that are connected also to the urban mobility. I hear very often that it is a questionable whether public money should be spent on innovation and on a designing of new product and new prospects and new projects. And as you can see from the table, for example, Tesla, that we all probably heard of, receive in a different state, local, or federal schemes up to $2 billion US throughout this history. So we see now the nice picture of the profitable company that it was based only purely on a venture capital, but this is not the case. And we see that, for example, in case of China, they are creating by stimulus and by the definition, the environment where they can be very competitive. And I believe in the case of electric buses, we see that China is really starting to dominate the market. A little bit about how we work. So we are divided in 5 different regions. So in the case of eUltimate, it's run by our friends in Innovation Hub Soft, based in Barcelona. But we also have thematic divisions, and in case of mobility and energy, I'm responsible for this thematic area, and I'm based in Prague, and I'm also Innovation Lifecycle Officer for East Hub. So part of the innovation, we have different thematic areas like business creation, factory, academy, and so on and so on. And just to give you a picture, this is the all network of 82 companies that are part of the our KIC. So once again, with different challenge areas and with different strategic objectives, these are the projects in innovation that we were supporting in our 3 years history. You can see in a case of mobility and energy and strategic objective 3, we see that there is a eUltimate as a project that has extension from 2021 also to 2022. So basically, this is about us. This is about the EIT Urban Mobility. If you have any questions or any questions how we work, how we can support you, please contact me directly or via our friends from UPC.
Thanks, Marián. That was a very good opportunity to learn about the EIT Urban Mobility, which is a very relevant initiative from the European community to unlock innovation in the transport sector in Europe. I will now hand over the floor to Miquel Estrada to have a presentation about the eUltimate. Thank you, Miquel. Welcome.
Thank you. Thank you, João, for this opportunity of sharing this project. Okay, to see my screen?
Yes.
Yes. Thank you. Well, my name is Miquel Estrada. I'm associate professor at the Technical University of Catalonia and the coordinator of this project. Okay, on behalf of UPC, I would like to give you a short overview about the project, the aim of this project, and how this project is organized. Well, first of all, everybody knows the importance of buses, okay, in providing accessibility and high performance in mass transportation. Nevertheless, in 2018, only the 5% of the total fleet around the world was powered by electric buses. Only this small portion of the total fleet. So of course, buses are a local or a major source of local emissions and greenhouse gases, and we have to activate and speed up this transition to battery electric buses in order to decarbonize the current bus systems. The problem is that the pace at which the technology has been deployed is slower than the pace that the European Union is establishing, okay, the environmental labels. So bus manufacturers are focusing just on a small set of different technologies. There is a wide spectrum of technologies, but each bus manufacturer is specialized only in one of the specific technology in order to reduce, okay, the local emissions. So our project is addressing this issue, and this project is aimed at providing recommendations, okay, for bus agencies, for cities, in order to choose the most suitable technology. So eUltimate will provide a vendor-agnostic decision support toolkit for assisting cities and bus agencies in the deployment of the most suitable electric bus fleet technology. By vendor agnostic is, okay, we are going to describe, okay, and we are going to recommend the battery pack, the capacity. We are going to recommend the charging schemes, okay, that are recommended for each special site. And after that, of course, we can go to the market and to identify the bus manufacturer that will fulfill our service. And we are going to do this process, okay, and to develop this decision support toolkit by means of the data collected in 7 pilot tests. Okay, so every month we incorporate a new city in the list, and right now we have incorporated another city, okay, and we are extending this network of collaborating cities. So our target stakeholders, as I said, are fleet operators and cities, okay, and in order to respond which equipment to invest on to fit my use case, so which is the optimal or the suitable technology in order to be deployed in a specific route. And in addition to that, or OEMs and tires in order to prioritize, okay, the investment in new technologies that may provide a successful performance. The ultimate partners, as you can see here, or the partnership is composed by 20 entities, okay, from 5 different countries, okay, based on this equilibrium between industry, administration and city councils, as well as research centers and institutes. Okay, so here you can identify the organizations that will do. So as I said, we are going to focus on the real performance of electric buses, so gathering data, and the pilot tests have been selected based on the different situations that these vehicles will perform. So we have chosen, okay, cities from the north to the east to the south of Europe in order to have the performance, or to check, to test the performance of these vehicles in warm weather or in cool weather, and in order to draw conclusions. Okay, so we will have a first pilot test in Milan and in Zurich. We have extended to Zurich, in the Czech Republic, and Hradec Králové and Zalaegerszeg. So as you can see here, the vast majority of the charging scheme tested are based on an overnight charging. Okay, in Zalaegerszeg, we are also analyzing the charging at the bus garage during the day period. And in the cities located in the south area of Europe, okay, we also check, okay, the overnight charging plus opportunity charging in Barcelona. In Badalona, these vehicles are really challenging because vehicles are providing service in the day period and in the night period. So the number of hours per day that these vehicles are on service is really high. So based on this performance, we are going to develop this decision support toolkit, okay, for cities. So this is what decision support toolkit will looks like, and it will be based on two major models. Okay, first of all, based on the data collected in different pilot tests, we are going to carry out a statistical analysis in order to analyze the real energy consumption factor based on the particularities and the features of each route scheme. Okay, so based on the slope, based on the weather, based on the humidity, and based off the size of the bus, we are going to calculate, okay, based on real data, okay, the energy consumption factor. And the second model will be the following. So based on these energy consumptions, we are going to identify the optimal combination of chemistries, battery packs, and charging schemes. So we are going to simulate, okay, the real performance, of electric buses based on these combinations of opportunity chargings at one terminal station, at two terminal stations, or during the service, okay, and intermediate stops, or the charging at the bus garage in overnight period or during the day period. So we would like to provide data to bus operators in terms of how many buses they will need in order to run the service. As far as we know, okay, the introduction of electric buses will increase the fleet size, okay, in each line in comparison to IC powertrains. We will also identify the optimal combination of chargers, okay, at the terminal station or at the bus garage. We are also contributing in the estimation of the optimal schedule of the buses, especially the schedule and the organization of charging operations at charging stops. And finally, okay, it's important, the total budget and the total investment needed in order to address or to undertake this transition to this decarbonization process. So that's all from my side. It's a pleasure to be here. If you have any question, you can contact us, okay, from this website, or email me if you have any question. Thank you.
Thank you, Miquel. Yes, we'll have some time at the end of the various presentations to have some questions by the participants in the workshop. So we'll have that opportunity. But in the meantime, as I said, if you have some questions, don't hesitate to use the chat also to send them over. Okay. I'll now hand over to Domingos Tavares, a fellow from Carris, who is going to present our work at the bus operator of the city of Lisbon in the eUltimate project. Domingos, go ahead.
So, I'm assuming you're all watching, right?
Yes.
Thank you so much, João. Hi, everyone. Thank you so much. It's great being here and having an opportunity to share a little bit of what we are doing regarding energetic transition here at Carris. And just an overview of our operation for those of you who are not familiar or are less familiar with Carris. We are the biggest public transport operator in Lisbon. Currently, we operate more than 720 buses and 48 trams. Also, we have 3 funiculars and 1 elevator. And all of this is done with over 95 bus lines and 6 tram lines. And as of 2019, so the last year before the pandemic, we had over 140 million passengers per year, which is a pretty good number. And to give you an overview of our fleet here at Carris, so as I mentioned, we operate more than 720 buses. Most of them are standard buses. We have around 530 standard buses. We also operate 90 articulated buses and other midi buses and mini buses. As you can tell, most of our fleet is operated by diesel buses, and as you can also tell, this is something that we are trying to change. And so this decarbonization strategy actually started in 2015 when we acquired compressed natural gas buses. Nowadays, in 2021, we have around 27% of our fleet is compressed natural gas, and we have also acquired in 2020 15 electric buses. So 2% of our fleet is currently composed by 15 electric buses. As you can also see, we have this goal and this commitment of becoming a zero emissions fleet operator by 2040. And this is something we feel very strongly about. And the acquisition of compressed natural gas buses and also electric buses exemplifies this commitment. And our motivation for eUltimate, obviously, eUltimate brings this unique opportunity for us to learn more about electric vehicles. This is a technology that we've been operating for over a year. We are still very recent in operating electric vehicles, and so having a chance to learn more about its impacts on our operation, how to plan it, it's great for any bus operator, and so it's great to be involved in a project like this one. And it's great to share with you also some of the innovation projects that we have in the scope of the decarbonization of our fleet. We have a chance here to present two electric projects related with electric vehicles, but also to mention this innovation project regarding circular economy. So at Carris, we have a couple of innovation projects. The first one, line 706, which is actually the first fully electric bus line in Lisbon. Also a circular economy project that I just mentioned, where we are using 100% reduced diesel produced from 100% used cooking oil. We actually took standard buses, normal diesel standard buses, and we started using this biodiesel, as we call it. And also we are running a small pilot with 3 electric minibuses in a central part of Lisbon. And the main point is to experience in real life the operation of 4 technologies. And so we have diesel, we have natural compressed gas, and electric operation, and also the diesel produced from used cooking oil. Go for eUltimate, and is obviously our one bus line, electric bus line 706. This is a fully electric bus line with overnight charging at depot, as Miquel had a chance to mention. All of our electric vehicles, so our 15 electric vehicles, the ones that we just acquired, are used in this bus line. And the main point is to learn and to compare how the operation runs comparing with other compressed natural gas buses and our diesel buses. We still have a possibility, and we are still studying, of sharing as well for the eUltimate project data from our mini buses pilot with our 3 electric minibuses. And to give you an overview of line 706, so it's actually an operational challenge. When we decided to operate electric vehicles, we wanted to do so in a way that we would learn the most about them. This is our first operation with an electric vehicle, and so it was very important for us to make sure that we could have and extract the most information about it as much as possible. And so we placed it in a line 706, which is kind of a challenge operation-wise, and that's exactly what we intended. For those of you who know Lisbon, we know we have very flat and wider space near the river, but as you go up the city and into the city, it becomes a little bit of a challenge because we have a lot of hills. And we wanted to make sure that line 706 and the electric buses will operate in a variety of scenarios. And so we have steep roads, we have narrow streets, we have an irregular pavement. It's very typical here in Lisbon. And we also have, and we give a chance for electric vehicle to also perform in a flat and wider road. And I showed you here, this is the longitudinal profile of our bus line. As you can tell, there's a lot of hills, a lot of ups, a lot of downs in all 9 kilometers, 18 kilometers both ways. And the main point is to see how the vehicle performs in different scenarios. So in a steep road, but also in a wider road, in narrow streets, but also in flat roads. The main point was to learn. Okay. I want to show you some figures. As you can tell on right, this is, well, if you don't know Lisbon, it's not very helpful, but the main idea is for you to see that it actually goes around the city center, and it starts near the river, goes back in the river. So all these scenarios that I just mentioned, we can test them. So far, and these are our current numbers, we have more than 1.1 million passengers already boarded line 706. We've performed and operated more than 390,000 kilometers so far, and with an average commercial speed of 14 kilometers an hour. Obviously, our buses, they charge at night, so they leave the depot in a given shift, they return after, and they, on average, perform 100 and operate on 116 kilometers each day. Our battery capacity is 240. The real battery capacity is 280, the nominal capacity. And so far, and this is an average number, we've been evaluated that it takes up to 0.56 percentage per kilometer of battery, which is a pretty comfortable number. And as of 2020, so the first year of operation of the line 706, we were already able to save 492 tons of CO2 that was not going to the atmosphere because we are operating an electric vehicle. And that is also a very nice figure to have in mind and to our goal in being a more sustainable bus operator. Okay, so our Lisbon pilot, 3 electric minibuses. Again, this is a much smaller operation. It's a much smaller bus line, but the goal is to learn as well. We've been operating these 3 minibuses since September this year, so it's roughly 3 months. We've already boarded more than 23,000 passengers, and these 3 minibuses compiled, they have run more than 7,000 kilometers and for over 12,000 hours. So 1,200 hours, sorry. And again, the goal is to learn. So we are looking at everything since maintenance efforts, since battery usage, how it behaves when it's a steep road, how it behaves when we need air conditioning. And we also want to know, and this is something I'll share with you, we are very keen in knowing what people think about our electric operation. It's very important for us. We are public transport, and we gathered some information from users. And actually, we got a 9 out of 10 score when it came to the operation of these 3 electric minibuses. And 97% of users actually said that it's very important for them that we are using electric buses instead of diesel ones. Also, to share some figures about our 3 electric minibus operation. As you can tell, we are measuring for each day the amount of battery they use and the kilometers that they perform every day. We've been quite surprised with these minibuses. They used on average 40% of the battery in each day, and they are running for an average of 78 kilometers. And so that gives us also 0.52% of battery usage per kilometer. This is still a very recent pilot, as I mentioned, only 3 months, but we are very impressed with the numbers so far. And the bus is, we are reaching a conclusion that the bus is actually pretty good when we are running and operating lines within the central part of Lisbon. So very narrow streets, very steep streets, and even in these steep roads, it's behaving quite well. So this is a very quick overview of our 2 electric projects and when it comes to electrification. And no doubt the future will be greener and public transport operators will have to shift to an all-electric operation. And so the eUltimate project gives us a chance to well appreciate how a decision support tool like this one can contribute to a better understanding of what our options of electrification are, but also the need to test and evaluate different models, which we are now currently doing. And this need will only increase in the future as we acquire more electric buses and as we electrify more routes. And so lessons learned from this project and from the decision support tool will optimize our pilots and our tests in the future. And this is a very quick overview of our electric operation here in Lisbon. Hopefully, if you have any questions, please feel free to ask at the end or in the chat.
Thanks, Domingos. That I think was a very good way to start discussing Lisbon's work on the eUltimate project. We'll now proceed to the presentation by Joanna Cunha of Instituto Superior Técnico, so the Technical University of Lisbon, who is going to tell us, to bring us from this more practical perspective to the simulation world where we can learn by modeling and take a lot of information to have better decisions. Joanna, the floor is yours.
Thank you.
Oops, I believe Joanna just left.
Yes, let's wait a couple of seconds to see whether she'll rejoin us. Yes. Great to see you again, Joanna.
I'm sorry, I had a little mistake on the button. Let me share with you my screen. Okay,
Yeah,
I think
yes, okay.
you can see my presentation now.
Yes, yes.
Well, hello everyone. Thank you, João, for your presentation. I am Joanna Cunha, as he said. I'm a researcher at Instituto Superior Técnico. We have been collaborating in this Lisbon pilot test and are working on the development of a new simulation tool that could help the operators, in this case Carris, better assess the performance of these electrified bus services. So as we understood from the previous presentations, we are now entering a new paradigm in the planning and offer of public transportation, where existing simulation models and decision-making procedures were designed based on the assumption that combustion-powered vehicles would be used. But with the introduction of these new electric fleets, will bring a new set of challenges and constraints to the operation. And as we've seen in all these presentations so far, one of the key issues that must be solved is the problem of how, when, and where to charge the electric buses, since the vehicle charging infrastructure in most cities is still too underdeveloped to support the large-scale deployment of the electric fleet. So existing models and the decision-making must be refitted or reformulated to face this new reality and take into account these new technical attributes and constraints that will impact both the operations and the fleet management. So it was in this context that we felt it was important to create a new simulation tool that would allow the operators to better assess the impacts of introducing these new electric fleets and identify its key benefits and shortcomings from the operational perspective. So we established three main objectives for the simulation model. First and foremost, it should be able to reproduce the currently existing electrified services where only electric buses are used and vehicle charging is performed exclusively at the depot. And through this simulation, we hope to help the operators to better assess the performance of these services and identify critical issues that might occur during the operation. As an extension of this primary goal, the simulations should also be able to allow expanding the scope of the model and analyze the outcomes of introducing this new technology in other lines. So the model should help to identify the most suitable candidates in other lines to introduce this new technology. And finally, the simulation should be able to run what-if scenarios that compare different charging schemes, which could help future investment decisions by highlighting the benefits of adding opportunity charging in each route, and by locating some of the most beneficial locations, or highlighting the most beneficial locations for these opportunity charging spots. This model is being developed in analogic and uses a blend of agent-based and discrete event simulation, which allows detailing the operations in a realistic way. Is being built to be concept independent, which means that all the parameters pertaining to the bus line under study and the technical specifications of the vehicles are input in the model separately, without affecting the core mechanics of the simulation. This means that we can easily transport this model to other case studies by simply changing the dataset. Furthermore, some model parameters can be adjusted to help simulate different operational conditions. So the user could try different fleet compositions and fleet management rules, or test different charging options. They can also calibrate the model using real data from the passenger arrivals or the occurrence of disruptive events in the service, such as, for instance, the battery drains or vehicle breakdowns. The outputs of the simulation are comprised of the set of operational performance indicators, but also analyze the power consumption and the state of charge of the batteries throughout the simulated period. To give a brief overview of the model features, this model is built on three main layers. The graphical interface is overlaid on a GIS map, which uses real GIS data to locate the bus stops where passengers are generated. The vehicle movements during the service execution are accurately reproduced, since they use the real road network. These movements are controlled by the logical layer. The logical layer is where the model's behavior is defined, and it controls not only the schedule assignment and the bus's actions, but also the generation of passengers and the behaviors of the arrivals and departures of passengers in the system. And they also support the testing of or adding to the simulation some random events that might affect the services. The final layer collects a set of statistical data about the simulated operations. So during the simulation, the user may survey some elements, such as the passenger satisfaction levels, by using indicators such as the average waiting times or the bus delays. They can also monitor the operations, collecting elements such as the work hours, the travel distances, the average speeds of the services, and also they can accompany the vehicle deployment throughout the simulation. Finally, they can also survey the power consumption in the line with indicators, and can also accompany here the state of charge of the deployed vehicles throughout the day. Apart from these elements, in each simulation run, the user can calibrate different, can use different calibrations to simulate several operating conditions in the model. So they can test different fleet compositions. So they can test having a fully electric or fully conventional bus fleet, or even they can try to simulate using a mixed fleet. They can adapt the fleet size and also adjust the number of vehicles they wish to deploy in each day. Currently, we have introduced 3 different schedule assigning algorithms to formulate the bus service, the service of each bus, and also added some rules to try to ensure a proper rotation of vehicles being deployed in each day. Finally, the user can also test different charging schemes in the model. To showcase some of the outputs of the simulation, I brought the results of running some scenarios. The first one compares the outcomes of using different route assignment algorithms when scheduling the buses. And looking at the passenger waiting times, we can see that the simulation results are very similar for all algorithms, with algorithm 1 achieving slightly less successful results. But this situation completely reverses when looking at the bus delays at survey start, where the first algorithm is by far the best at ensuring the compliances with the compliance with the service schedules. So this illustrates not only the model's ability to consider these different decision-making rules in the planning, but also the model's sensitivity to these different calibrations. The second scenario I'd like to show you was testing different charging options. So we compared the existing options where vehicles only charge at the depot, with the option to install a charging port at either the Caixo do Sodré terminal station or at Santa Apolónia, and even the option of installing charging points at both terminal stations. When analyzing the state of charge of the batteries of the deployed vehicles during the simulation, we can draw 2 main conclusions. First of all, this bus line is short enough that it can be comfortably executed using only overnight charging, which is perfectly consistent with the practical experience of operating this line. The second conclusion we can reach is that, according to the simulation results, they indicate that if a charging point were to be added in this specific route, the best solution would be Terminal 2, with the added value of adding charging points at both terminal stops being very marginal. So these are still some preliminary results, but they indicate that the simulation is robust. We are currently verifying and fine-tuning the model, and we'll be validating the simulation results with real operation data provided by Carris, and we hope to finish this process by the end of this year. After this step, we will be able to expand the scope of the model and try to simulate the electrification of other lines. And finally, as we gain more knowledge on this reality of operating electric vehicles, and we start to anticipate the future technical features, other technical features, the model will be expanded to accommodate these characteristics and the influencing factors that shape the new paradigm of electric mobility. So this is all from me today. Thank you very much for your attention. And
thank you, Joana. I think that was very, very interesting. So we'll now move to the presentation of André Castro from ALMA Design, and that will provide us more view of the future of what the decarbonized city can look like. André, go ahead.
Yes, thank you, Domingos. Thank you, João. Thank you very much. I will just share my screen. Can you see it?
Just not yet. Yeah, now, yes.
Okay, okay. Thank you. So I'm here on behalf of ALMA Design and been working here with Carris and also with Instituto Superior Técnico in Lisbon to develop this AAT urban mobility project. So I will start by explaining what we did firstly, what we call the stakeholders matrix. We try to understand how does the electrification of public transport improve life for people in the city, and also how we could address the goals, needs, and actions of different stakeholders in this project. So we try to develop a user-centered design approach to address topics like public acceptance, operation, maintenance, city planning, things like this. So really looking at all the stakeholders together and trying to achieve what we think could be a solution and what this solution will mean for each one of these stakeholders. So the approach was to integrate operations on one side. Of course, we have Carris, also to try to integrate the physical infrastructure, bus shelters and other ways of transport. Also trying to think about the social context and also the governments and public entities involved. So this was our first model and first approach. So on line 706, we looked at operations, physical infrastructure, government and state, and also social context. And so starting with operations, we first looked at the operation from the Carris point of view. So from the drivers and supervisors, also from maintenance side, operation planning and monitoring, and also for the passenger side, okay? So for each one, the electrification of the line could have different results. And so we looked at the drivers and how they could have different contact with final users. Also the supervisors that define schedules, plates, shifts, things like this. Also in terms of maintenance, because this is a different technology bus, this would mean that the maintenance issues would be different, but also that electric buses will provide new opportunities because they require also less maintenance after the operation is, let's say, running smoothly. In terms of operation planning and monitoring, also these electric vehicles, as we just seen with Joanna's presentation, can offer potential increase in efficiency, but we now have to model how they work, how charging is made, and how efficient the lines are. Finally, for passengers, of course, there's a great opportunity for the electrification because the silent zero emissions bus would help improve the passenger experience. Then we try to look also at the physical infrastructure and what we could do to improve it. So the bus shelter and transport hubs are now prepared for diesel buses and not the electric buses. And also in the latest years, as we all know, a lot of different systems and last mile systems have been offered also in cities. So we try to understand if there was an opportunity to improve the transport hub and the bus shelter in order to accommodate all these new technologies and solutions. We also spoke with manufacturers as the electric platforms will improve, and possibly also improvements in battery technology will enable the current buses to operate in different lines. And finally, also with manufacturers from the charging systems in order to understand how to integrate them in the bus shelter. In terms of the municipality, of course, there are different players and all the authorities managing the operation. So it's also important to see how they can react to such a project in order to make them better manage the public space together with the operator. Also, the strategic objectives in terms of urban mobility, the system, the planning, the organization, the operation, allocation, all these issues. And finally, looking at the community and the culture also. So understanding how residents, businesses, associations could improve and get, let's say, best results from this kind of operation, and the kinds of improvements they would require on the service, pricing, infrastructure, and also in terms of design to try and have this opportunity to build better spaces and improve public transport operation, passenger experience as a whole. So really trying to look at the whole operation as an holistic problem and trying to use design methodologies to address it. So as Joana also presented the 706 map at this stage. And we also highlighted here a lot of operations that Carris is doing. So the bus route is going through co-work spaces, startup hubs, industry companies, universities, entertainment spots. So we are really in the center of Lisbon. So we are addressing a lot of different possible users. And so this was a mapping that we also thought was important in order to promote the public acceptance of this project. So in terms of future, how then would we envision the station of the future by looking at all these different stakeholders' needs and aspirations, let's say? So we looked at it as what if we need to include this opportunity charging when operating different lines at specific terminals, as Joana mentioned before. So this is not the case for line 706, but when we start using other lines, so would it be important to include opportunity charging? How to do it? Also, how can we design a future bus shelter that could work and function as a multi-modal hub? So include the charging points, but also the bus stop and maybe other mobility infrastructures such as bike sharing or scooter sharing and systems like this. And so what is the best way to integrate this solution in the urban landscape also by connecting different modes of transport and also probably with the urban and landscape design. And our proposal basically aims to integrate the bus shelter with connectivity, infotainment for the passenger, bike lanes and docks, and also scooter lanes and docks, opportunity charging, and also the landscaping and urban integration. And so this is our proposal, where we are trying to integrate different modules. So module 1, which includes the bus shelter, the infotainment for the passengers, of course, some signage and graphical interfaces. So we could, of course, know in which terminal we are, also seating and also protection from the environment. Then a second module where we could have the pantograph with rooftop connection to the bus, and we can make a quick charging of the bus during operation at the terminals. And also a dock-based bike share system, or could be a scooter system that could also be operated by using a screen on module 2 or using the space in between module 1 and module 2. So this would mean that we could operate in the city and have a use of both the landscape and both the urban equipment and the bus shelter to integrate different modes of transport and make this, let's say, a multi-modal hub by integrating also the opportunity charger in the best way possible in the urban landscape and city planning. So what we can see here is the bus charging. In this case, the batteries at the back. And so this would be the total integration of the bus with the different bus shelters. So we could also envision that in the end, as a conclusion, we can say that we can try to promote the electrification of bus lines by promoting discussions between different stakeholders. We also can include final users, operation, municipalities, urban planners to promote the public acceptance of the project. And finally, we can integrate the solutions in an holistic approach by promoting this modular designed station of the future hubs that we think could be the future of the electrification of public transport in Lisbon. And this is it. Thank you very much.
Thank you very much, André. So I think we are quite well on time. So I would suggest that you take this opportunity to have, let's say, a couple of questions to some of the speakers today. So I don't know, I think there is a raise hand functionality. So if you want, or if you just want to use the chat, so I wonder if someone would have a question for any of the speakers up to now. So there is something that doesn't change between face-to-face events and online events, is that breaking the ice is always challenging. So perhaps I'll go ahead with a question to Joanna Cunha. Just to clarify one point. So you mentioned that you are building the model in a way that it will in theory change between the change between contexts would be easy. So can you tell us, for instance, whether it would be possible, how could it make it possible, for instance, for testing a new bus line in Lisboa, or even for testing in your model and running in your model a bus line in Madrid or Barcelona or whatever?
Well, thank you for your question. So basically, when building the model, we have that graphical interface that is in the map. However, the information about the stops is not directly linked to the map. So when deciding where to put the passengers and where the services will stop, the model is actually extracting that information from a set of databases. These databases have all the route schedules, the stops, the average speeds of the vehicles throughout the day, and the passengers' information. So by changing that database, what would happen is that the model would be using this new information to locate the services and all the elements that make the bus line. So it's not linked to the little markings we have on the map. It's actually using all the geographical data that is on the databases. So it is simple to change from one case study to the other by changing this database. Okay,
thank you. So I don't know whether someone else would like to make a question.
Yes, João, I have a question to you or to Domingos that is pretty much related with the challenges that a public transport company face in the current paradigm. So I would say, and this is my opinion, so this can be like the first question, it is not only so having to deal with the new technology, in this case with electric vehicles, but it is also the transition period in which you have one paradigm, carbon-based, to another paradigm, electric-based. And so over time, you will start with the majority of carbon, then you start introducing the electric, then you have a mix, and then you have the majority of electric. So totally different technologies, different autonomies, different reliability levels, different levels of maturity. So, and you have to still maintain your high levels of performance to the customers. So do we agree? So first question, do you agree with me? Is this transition still a very delicate moment, or no, it is just current business? And what kind of key challenges and therefore mitigations actions do you expect to implement, and kind of problems do you expect to solve in the coming, let's say, years during this transition period?
Yes, maybe I can take it. So I think you touched on a very relevant point, because this transition will have impacts in nearly all areas of our company. So it ranges from the fact that we used to have maintenance systems based on a single or maybe a couple of technologies, but a much more single technology. And now, at least for a number of years, we'll have a wide diversity of technologies in our fleet, because it's not only the fact that we have vehicles with natural gas, diesel, and electric, eventually hydrogen, eventually biofuels. Is also the fact that we have different vehicle typologies. So we have minibuses, midi-buses, articulated, standard. So you can imagine the amount of combinations that you might have here. So and that's something that it's very relevant. This is just one example, of course. Then in procurement processes, that's also challenging, because we are procuring something completely new. So we have to know what to put on our tenders, and how can we evaluate, and what are the key parameters. That's why we make, for instance, tests like the ones that Domingos was just describing, is to increase our own maturity about the technical characteristics of the vehicles and our actual needs, okay? But one aspect that I would like to underline is the fact that we have, like Domingos presented, 95 bus lines. And within these bus lines, we have very different realities. So we have bus lines like 706, in which we kind of did our assessment and knew that, like Joanna showed, operating electric vehicles with overnight charging would work. So that's a line, let's say, in which we're confident that we could work with these kinds of vehicles. So the results of the model don't surprise in a way. But then there are 94 other bus lines out there. So we are going to buy, say, a standard electric buses or a mini electric buses. Where are we going to put them? Do we need to change the timetables of the lines? Do we need to change the lines? Is it better to have opportunity charging? Where to put the opportunity charging, like the model was that Joanna is working on, can help us identify? How to integrate the charging, like Andrea showed, and I think that's very important. Then specifically when we come down to the location, I mean, we as a bus transport operator, we are here to work for the city. So it has to be well accepted by the stakeholders, otherwise it's not going to work. And so this is, in the end, I think the main motivation for us to be here in eUltimate is because we need help to guide us through this transition, because we kind of know that in 2040 we'll have 95 bus lines or maybe more, and they will all operate with electric buses, but today we only have one. So we have to find our way to guide us through this transition, and that's of course a very important challenge.
Thank you. By the way, I have another question, very quick question to André, that we have already discussed this in the consortium, but I also like to raise this here in public. So, André, when I look to your very interesting concept to this new generation, my question is, in this eUltimate project, we are focused on the bus, on the public transportation, but they can be enlarged to become truly hubs, mobility hubs, because more and more we are talking about multimodality, so integration with other modes of transport, like scooters, other kind of mobility options. So do you see this concept in the future evolving towards the incorporation of such mobility options?
Yes, thank you, Vasquez. For sure, we think so. Yes, because all these new systems have been appearing in the last, let's say, 5 to 10 years. So they are new, and all the bus shelters and this kind of infrastructure is something quite heavy that stays for a long time. And as we see them now, we think they have to integrate these different modes of transport so that you can actually flow in a city in a much more, let's say, seamless way, right? And also this has been happening, as we all know, here in Portugal with the pricing and the passes and the tickets. So now we can go in different public transport systems by using the same ticket. And all this integration also indicates that we should try to use the bus terminals as a hub point where you can have different modes of transport and can really, if you come with a scooter or with a bike or by foot, then you get the bus, then you go out and you have another scooter or whatever you want. So you can really make this last mile and make decisions will help you get to where you want to by integrating different modes of transport in a seamless way. So for sure, we think this is the way to go further.
Perfect. Thank you.
Good, thank you. I don't know if there are any more questions or comments, but in any case, I think we should proceed with our meeting. So I will hand over to Vasco to introduce our keynote speaker.
Yes, thank you so much, João. Yes, so indeed it is. I'm very happy to have with us here today Paulo Manes. Paulo, are you there?
Yes, I am.
Perfect, great. So Paulo is an executive in mobility business development, an innovator and a leader in the mobility industry. I know him for many years and he has more than 20 years of experience in the sector. So I would say that it is a great pleasure and very positive for Portugal because he was abroad and since a few months now, he's now in Portugal. He's a director of mobility, city and automotive at CEIIA. And for those that do not know, you should know it. CEIIA is a very important research center here in Portugal. It's the Center of Engineering and Product Development, and it is pretty much related with everything that concerns the mobility industry, automotive and urban mobility, or aeronautics, ocean and space. So they are in very different areas. So Paulo, once again, thank you so much, and the floor is yours.
Yeah, thank you. So I hope you can see my screen.
Yes.
Yeah. Okay, so I wanted to talk to you a little bit about mobility and mobility as part of an ecosystem, because in reality, public transportation is part of a mobility ecosystem, and that is more and more going towards a decarbonizing system. So I want to explain to you a little bit about what I see as the vision for the future and how that impacts what we are trying to achieve. So I want to start in the past and not looking towards the future. This is a picture of New York in about 1894, I think it is the year. And you can see that it's a lot of traffic and it's mainly horse-drawn carriages that are circulating. And you'll see that I've highlighted, it's a car and it's one car in a multitude of horses. And in 20 years, so about 1914, this was the same New York, and you would struggle to find the horse. Again, it's highlighted what it is, but the internal combustion engine had completely revolutionized mobility and have, in a way, revolutionized the world as we know it. And today, we are still dealing with a lot of the problems that has brought us. And it's not an easy or clear path on how to do it. But I do believe that currently we are in a very similar period in time, albeit more than 100 years later, where not necessarily a single technology, but a combination of technology is significantly affecting the way that we move and the way that we will move. So I want to talk to you about the International Transport Forum and the work they've done on the city of Lisbon. So about 6 years ago, we decided to do a study as the ITF and the Corporate Partnership Board, so a group of private sector companies, to try to identify what would happen to Lisbon if we were to replace every single trip that is taking place on the road, and that, by the way, includes buses, to a private individual shared autonomous vehicle, a bit like this one that you see here. So we decided to model what would be this impact. And we wanted to leave a similar level of service compared to the private car that we have today. So a bit like the Uber, we said that the maximum anybody would have to wait for a vehicle would be 5 minutes. So very close to your level of service that you have with your own private car. And with that, we decided to also keep the core in Lisbon, which was the metro system. As I mentioned, we removed all the buses and we converted them to these strips. And with that, with all the trips being transferred, we realized that you would only need 10% of the automotive fleet to serve exactly the same trips, So that means that 90% of the cars that are in Lisbon do not need to be there. But of course, that is not necessarily true, because during peak hours, to serve the trips during that peak time, we still needed 2/3. So about 30%. But that would mean that every 2 out of the 3 cars that are in Lisbon do not necessarily need to be there. And of course, can you imagine what that will happen with regards to parking? There would be no more parking problems in a city like Lisbon. That would be the equivalent of 230 football stadiums worth of land that would be available. Okay, imagine what a city could do: parks, cycle lanes, etc., 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 whatever you want. But of course, the study was not all good news, because although there was less vehicles, the vehicles would never stop, and some of the time they were running without any passengers inside, and that would mean that they would make more kilometers than the fleet that we currently have. So that would not necessarily be a good outcome. Of course, that is mainly because of pollution, but we can imagine that would be very easy to replace everything with electric vehicles and solve the problem. To be fair, that was the case. We needed a small increase of about 1% of the fleet due to range and charging issues. At that time, we were still in an infancy. I think now it would be better, especially with regards to range and charging time. But as I mentioned, we took out the public transport, and in particular the bus, from the system. So we decided to put it back, but we didn't want to put it back in the same way. So what we decided to do is to introduce 2 new vehicle types, one with 8 seats and another one with 16 seats. So similar to the minibuses that Carris is running. And we wanted to make them on demand as well. So the level of service was not 5 minutes, was actually 15 minutes. And the other thing is we would force people to walk up to 300 meters to minimize the disruption of the bus having to deviate to pick up those people, to minimize that distance. With that system in place, we were able to improve the fleet numbers by half. What was then 10% became 5%, and what was then the 30% became 15%. And overall, it brought a reduction of about 20% on vehicles, total vehicle kilometers that would travel. So it showed how important an ecosystem is and how important the public transport, and in specific the bus, has on such systems. So it was very, very important to understand this. With this understanding, I wanted to explain to you, Lisbon has also wanting to evolve and needing to evolve as a city and as a sustainable. And as you all know, in 2020, Lisbon was the European Green Capital. And like every city has aspirations of being a smart city. But of course, that will not be possible without some changes. And I want to explain to you why in Portugal and why we are getting to what I want to get to in terms of defining this mobility ecosystem in Portugal and why it should be completely decarbonized. For those of you that don't know, in 2016, Portugal was the first country in Europe to run for 4 consecutive days on renewable energy. Okay, this was a very important point because one of the things that Portugal thinks is one of his weaknesses became one of his biggest strengths, which is our size. We are a small country, but we are in a location where there's a quite significant amount of sun. Because we are in the Atlantic, really, we have a lot of wind. So it's a perfect location for some of this renewable energy to take place. And we embarked in this adventure, but we realized that mobility in particular is very addicted to the oil-based energy. So in Portugal, there we had, like in most countries in Europe and around the world, Uber came along and the taxi drivers and the community revolted. But we in Portugal saw it as an opportunity. And we were one of the first countries in Europe, we were the first country in Europe to have legislation specific about Uber. And most people do not realize, but one of the conditions of that was a certain amount of electric vehicles in the service, what is now Uber Green. Uber Green is used for the first time ever in Portugal and specifically in Lisbon. That was where the innovation was born for an Uber that was based on electric vehicles. And also the setting of the price was also defined as the cheapest mean of transport, although it's comparable to the Uber X that you now have. Following that, there was in Portugal started to have a widespread of electric vehicle charging. And we were one of the first countries in Europe to have a significant investment in electric vehicle infrastructure. And today, Portugal is one of the leaders in electric mobility in what you can pay with a single card, almost every point of charging in Portugal, whilst in other countries, you need a multitude of cards. Where I was in Germany, I had 4 or 5 cards in my car to be able to charge my car. In Portugal, I only need 1. Okay, that is something that really has changed. And we realized that we needed to learn from that experience, also to understand how electric fast charging was required for some of the applications. The Uber is the typical example where the vehicles are being used 24 hours a day. And that enabled companies like FSEC to really stand out in this market. And I don't know if you realize, but most of the world's fast chargers are actually engineered and designed in Portugal. Independent what brand they have on top, they are very common throughout the world. And of course, that advent and that openness to electric mobility brought the advent of electric mobility being at city level. And I believe Lisbon at one point has had something like 17 different operators operating in Lisbon. And that was very important that we realized. Of course, with its problems, but very early on, Lisbon was able to come up with some of the responses to that by organizing parking, by organizing the movement, by understanding where things were. But one thing became clear is that this electric micromobility would only work in complement with public transport. And public transport really was not necessarily attractive because of pricing. And that has forced the Portuguese government to intervene, and in the major metropolitan areas has decided to cap that cost. And so a monthly pass can only cost, guys, correct me if I'm wrong, but I think a maximum of 40 euros. So it enables public transport to really become competitive. And at many points, the combination between public transport and some of this micromobility, some of this electric mobility really makes a lot of sense. And that has really enabled some changes. And it enables the use new things, new thoughts of using land. For instance, this is a car park in Lisbon where the rooftop is a bar. And we can now think about using, for instance, car parks and using this space in a completely different way. What I was saying to you about mobility really being able to transform the spaces, it's already starting to happen, and you can really see that. And why not? There will be new mobility being on the river in Lisbon by sea or by river or by air, and that's something that we are all working on. And importantly, what I wanted to tell you is that Portugal really put a green light on this new innovation and thinking of the ecosystem. And that's why it's so important to us here at CEIIA. And what we are trying to do is to think that mobility in a decarbonized world and in a form of an ecosystem. And we want to do it in different ways. We want to think about bikes, because bikes are a leveling way to communicate and to move around. And it makes no sense that, for instance, today you cannot transport bikes, for instance, on a bus or in metro systems. Sometimes it's difficult. There needs to be some flexibility, and that ecosystem needs to be thought through. And this ecosystem, it's not only physical, but it's also in the cloud or in a virtual world. So that's exactly what we are thinking of, and developing this new generation of bicycles and two-wheel devices that really are modular. The same with the car. We need to rethink the car, not in a private use, but in a use of shared use and thought for use mainly in cities, and not a car for everything. We tend to buy a car that serves a function for one day, and it's the extreme of one purpose, and yet we use it every single day, and that makes no sense. And of course, we are working in particularly very close with Caetano in helping them develop the next generation of buses, because we talked about it, that the bus is really an aggregator and serves a really unique purpose. And Caetano, for those of you that do not know, has joined forces with Toyota. So now for their sustainable mobility, so they have buses which are electric with a traditional battery cell, or with a hydrogen cell for longer trips, for those that we were talking about that might cause trouble with relation to charging and so on. We need to develop not only the physical infrastructure where all these buses, bicycles, cars are being charged, are being able to use, but also develop the platforms, the digital platforms that enable their use, and the blending between the different systems and working as one in a city environment. And that requires a lot of work with regards to technology and creating cyber-physical products, not only physical products. And that's really what we are working on, because we believe that that's the only way that we will make a difference and we will change things. And that has to be data-driven. And one of the things that the pandemic has taught us is that big data is not necessarily the right data for what we need. So we need to have intelligence, and we need to understand that intelligence and not just keep data for the sake of keeping data. And that's the only way that we will really have a sustainable, decarbonized transport system. And that's what I wanted to lead it. Okay.
Paulo, thank you so much for your inspiring presentation. I have several questions, but first of all, I will like to ask the audience. Please, if you have any questions, I believe your mics are open, so you can simply unmute yourself and raise a question. So please go ahead. So if not, I have a couple of questions, Paulo. First of all, for sure, you and everyone, you should have read today in the news that the Commission is preparing to bring Portugal to justice because of the emissions in Lisbon. Again, they are above the maximum threshold. And so the Commission is demanding from the Portuguese and from the Lisbon municipality additional measures to reduce the emissions and to bring it to the legal levels. So first of all, the mobility is of course an important contributor to this problem, and the public transportation should play an important role. I'd like to hear your thoughts on this. On the one hand, on the other hand, in looking to the future and also bringing some of your images here again about the future paradigm of living in the city, where we can have not so crowded with cars, not so crowded with roads. For sure, we will have a lot of other economic activities. So, what will be the impacts that you expect? Not only not from the mobility perspective, but also from the social and economic point of view, because we have now several examples right across Europe in which this movement of bringing the city back to the citizens is also an important leverage to other economic activities. Do you have any comments on this?
Yeah. I will answer your question with a little bit of a story, and it's about Paris. In my previous life, I was part of the Mobility Council of the City of Paris, and I had a number of discussions with the mayor, Ana Hidalgo, and one of the interesting things is she told me we want to forbid internal combustion engine cars in Paris by 2030. And the reality is 2030, it seems a bit unrealistic. You're not gonna really be able to do it. And what she told me was, it's very interesting because what she said was, yes, but we want to do it so that people cannot make the change. And we want to use the Olympic Games as the catalyst to make that change. And the reason why we don't want to make that change, and we know people will not be able to make that change, is that will enable us to develop the infrastructure of an ecosystem that will enable us to change the city completely, and that people will realize that they do not need the private car, and that actually that brings them greater quality of life, better city environment. And that really is what enabled the transformation. And they wanted to use the Olympic Games as the catalyst for that operation. And that shows very well that's what we need to do in order to be able to change. I know that politically this is sometimes difficult. I know that politicians work in a 4-year cycle that makes this changes even more difficult at local level. But it's something that we need to really think, because if we really believe in sustainability, is about what we're going to leave for the next generations. It's not how we clean or not. And if it takes a little bit of time, it takes a little bit of time. But also do not think that a completely 100% electric mobility system will get rid of all the problems. Okay, there are emissions resulting from electric vehicles. There are dust from brakes, from tires, from the production, as we all know. It's very controversial, but we need to work towards that goal. And that goal has to be that, we need to reduce, so we need to understand the travel, so manage it that way. But then when we have to make that movement, we do it with the best device that we can in the most efficient and sustainable way possible, and not as we do today, which is let's go to use the car because it's sitting outside. I already pay for the insurance. It has fuel, so I don't have to worry. And that's the transformation that has to take place from my point of view.
Perfect. Thank you. Thank you so much for your comments. I don't know if there is any further question from the audience. If not, I will leave the floor to João. I believe that we are coming to the end. So thank you so much, Paulo, once again.
Thank you.
João?
Thank you. Thanks. I would like to also thank Paulo for this very inspiring presentations, and also to our colleagues from Barcelona. So to Miquel to join us today, and to Martin from the EIT to also have participated in this event. So I think we are also reaching the time that we had allocated for this session. So I hope it was a good opportunity to learn not only about one innovation project in Lisbon, but also to have a better inspiring view of the changes that we are experiencing in urban mobility. And I would like to finalize by reminding you to follow the work of the project if you're interested, of course, in its website. That there will be another general event in which we are going to present the results of the project and show the working of the decision support tool, which I believe might take place in early next year, maybe even in January. So if you'd like to keep on track with that, just follow the website of the project, and you'll be very much welcome to join this event. And that's it from my side. Special thanks to all the speakers, to all the participants, and I wish everyone a very nice day. Thank you.